Okay, hi everyone. Today I will talk about an interesting pattern that we began observing when we looked at many Indian taxa, built phylogenies, plugged the Indian taxa into the global phylogenies to look at their evolution. And what we basically observed were what I call endemic radiations. And let me get more into it in detail in a bit. So the title of my talk is an island called India, phylogenetic patterns across multiple taxonomic groups reveal endemic radiations. And this work is published in 2005, and here's the paper that where talk more about endemic radiations. But since then, there have been many more studies, and so I've sort of updated that in this talk here. And I'll also contrast endemic radiation with island radiation in Madagascar. So that's something new that I'll be talking about. Okay, so as we know that the Indian plate is geologically very interesting. I've talked about this before. India was part of the Gondwana supercontinent about 200 million years ago, and about 170 million years ago, this continent began to break apart. And India and Madagascar separated from West Gondwana about 120 million years ago. India separates from Madagascar about 85 million years ago, about 80 to 90 million years ago, and eventually begins to move towards Asia, right? And then collides with Asia around 55 million years ago, and eventually merges with Asia about 35 million years ago. So for about 50 million years, India was an island, a drifting plate, a drifting island. Uh, so after collision, what happened? Well, after collision, there was faunal exchange, and I've talked about this in some of my earlier talks. Basically, Gondwanan elements dispersed out of India, and Asian elements came into India, right? And the elements that came into India, we call them intrusive elements because they sort of intruded into India. So basically, we have two broad categories of faunal affiliation, if I may. One is the Gondwanan element, the other one is the intrusive element. Okay. But something else very interesting happened when India collided with Asia, and that is the emergence of the Himalayas, right? Now, if you look at Himalayas today, it's like a wall that separates India from rest of Asia, right? It's really high mountain range with climatic conditions that are very severe compared to the rest of India. So it's a wall that surrounds India, and to the south, India is surrounded by the Indian Ocean. So in a way, this subcontinent, after collision and rising of the Himalayas, was physically separated from the rest of Asia. So it sort of became an island again. So upon the initial collision, the Himalayas had not really risen as much, so there was easy movement of flora and fauna. And then the Himalayas rose rapidly, probably then cutting off India from the rest of Asia once again. And maybe in the northeast, because the mountains are not that high, elements could move in and out. And in fact, Mani calls it the Assam gateway. Anyway, so India became an island once again because of the rising Himalayas. Now, this also had climatic implications, right? If you look at the rainfall map of India, you notice that India is surrounded, not exactly surrounded, but to the north and to the east, um, there is arid zone. So you have the cold desert here, and you have the hot desert to the northwest, thereby again separating India from the rest of Asia. Whereas in the northeast, there is more sort of a contiguous climatic regime. So geography has also influenced rainfall regime. So both geography and climate sort of isolated India from the rest of Asia. So India sort of, after collision, much after collision though, India sort of remained an island. That's the way I look at it, right? But how did this idea come to me that maybe India was an island? This was after we built many phylogenies, and I'll come back to that in a bit. But now let us talk about what is so special about islands. But before that, due to its unique geological history, India has been isolated from mainland Asia in the past, right? So while it was drifting, it was an island, and its current geography, as well as the climatic conditions to the north and the northwest, has maintained this isolation. So India is like an island compared to mainland Asia. Right. Now the question is, does the origin, distribution, and diversification of Indian biota reflects this isolation, or has this isolation um, shaped diversification within India? Right. Okay. So here's an island of Madagascar, and I'll come back to this island a little later. But what is interesting is that islands have long provided an exciting setting for evolutionary research. Both Darwin and Wallace were deeply influenced by peculiarities that they observed on islands. Now we know Darwin for his work on evolution by natural selection, but let's not forget that Wallace was the co-discoverer of this theory, and Wallace was a biogeographer, one of the earliest biogeographers, and so basically what they observed in the islands provide the basis for their theory of evolution by natural selection, right? And let me talk to you about what Darwin observed in a bit. But what we see in islands is that islands tend to have unique biota due to their isolation, right? And often after an island is formed, you have colonization of elements from the mainland, and because of isolation, only few lineages make it to the island. So often islands are depopulated. And then, because there are many open niches on the island, what you see is colonization followed by in situ diversification within the island of this lineage into multiple species, right? And these are called island radiations, right? But in the case of India, turns out there are radiations in India too, and I call them endemic radiations because technically speaking, India is not an island, even though I'm calling it an island, but it's now merged with Asia. So what you see is a single colonization followed by diversification. And when you build a phylogeny, where you sample species, say, of a particular genus from the mainland and from the island, all the species from the island are monophyletic. They branch together. So there was a single colonization followed by diversification, right? And the island forms are nested within a larger phylogeny consisting of species from the mainland. So you can think of South America and the Galapagos, Africa and Madagascar and so on, right? Okay. So as I said, Darwin was deeply influenced by what he saw in the islands, particularly in the Galapagos Islands. And in the Galapagos Islands, we have finches, and which are today called the Darwin's finches. And what he says is that seeing this gradation and diversity of structure in one small, intimately related group of birds, right? So he's commenting here about the beak shape. Okay, one might really fancy that from an original paucity of birds in this archipelago, one species has been taken and modified to different ends, right? So what he's basically saying is that there was a probably a single colonization of these islands by the ancestor of all the finches we see there today, and then because there were many uh, open niches, because there was paucity of birds there, there were not many species of birds already existing there, so there were many open niches. So this lineage then underwent diversification, right? Uh, in fact, people have now shown that indeed the Darwin's finches are monophyletic and they are related to warbler-like finches, warbler-like birds from mainland South America, right? From South America. So they are in fact monophyletic, right? So you expect, radiations to have to have members that would be monophyletic. So this is single colonization followed by in situ diversification, and in islands we call it island radiation, and if it is in the mainland I usually call it endemic radiation, because all these species are endemic to that particular piece of land. Okay. Now, endemic radiations are not confined to islands, turns out, right? The rift lakes in Eastern Africa, these are lakes that are in the Rift Valley in Eastern Africa. Now, these lakes each harbor radiation of cyclic fishes. So these lakes can be considered as an island in a sea of land. So these are really large lakes, right? And they are like islands in a sea of land, and they're isolated from each other. And within each of these lakes, you have radiation, right? So again, one lineage radiating into multiple species. And people have also talked about mountain tops as sky islands, as they provide islands of distinct habitats when compared to lowlands, right? Such mountaintop habitats are also known to harbor endemic radiations. Of course, these mountain tops have to be large or continuous, so you then have a large area which is very different from the rest, and lineages that make it there, adapt to that environment, then undergo radiation. You see this in the Tibetan plateau. So a lot of the Chinese work has shown that, on the Tibetan plateau, you have many radiations of plants and animals. Okay, the common theme in all these examples, lakes as well as sky islands and islands, is its evolution in isolation. The physical isolation of these areas, in conjunction with the presence of unoccupied niches, which is a consequence of the isolation, has provided an ideal setting for diversification. So the lineages that do make it then undergo diversification. So what about India? Right. So I set up this talk by saying that India is an island. To the north there are all these hills, mountains, and there's the climatic barrier too. So the question is, does the origin and evolution of Indian biota exhibit signature of this isolation? Okay. Now let us look at an hypothetical example. Let's assume that a group that we're looking at, some genus X, has a Southeast Asian origin, and if island hypothesis were to be true, then obviously these species from India would all branch together. It would be monophyletic, nested within a larger clade consisting of Southeast Asian forms, and these would be sister to the Indian forms. So the Indian forms would be monophyletic. However, so this would be a single dispersal into India followed by radiation. However, you could also have a situation where uh, this is a tropical Asian radiation, and there's multiple dispersals into India, right? So the Indian forms then would not be monophyletic, right? Now, where did all these ideas come from? Well, when we were working on many of the Indian groups, we began to realize that indeed many Indian groups are monophyletic, right? And it looks like there has been a single dispersal into India. Here's an example of Lemurs. There was a single dispersal of genus Semnopithecus into India about 8 to 10 million years ago, followed by a radiation which resulted in about 7 to 8 species. And this looks like it's a dispersal from Southeast Asia because all the other sister groups are found in Southeast Asia. Here's an example of another endemic radiation, the Hemidactylus clade that is confined to Indian subcontinent. It is monophyletic and it is sister to Southeast Asian clade. And this appears to be another sort of dispersal into India, post India's collision with Asia, followed by radiation. Right. Okay. In fact, we found this in many other groups, right? So I already talked about many other lizard groups. I already talked about Hemidactylus geckos, and in Geckoella you see the same pattern into India from Asia. You see this in skinks. So that really got me thinking that why aren't we seeing a pattern where there are multiple dispersals into India? Why do we see a single dispersal and a radiation? So clearly, this landmass has been isolated, thereby providing this setting for the radiation. And therefore, we think India is like an island today. Okay, we have also seen this in plants. I should just point out that a lot of this work is actually from my lab, and the gorilla work was done by Ishan, but then this part of the story was already known earlier. Roy did a lot of the skink work. Rohini and Aparna did a lot of the Hemidactylus work. Now, what about plants? Now, Siddharth, who was a postdoc in my lab, did some work on this genus called Ceropegia. And Ceropegia is found in Africa and in Asia. So we knew that it's a dispersal from Africa into Asia earlier, and of course the phylogeny confirmed it. But what was interesting was indeed there was a radiation in India consisting of about 50 species, right? So we have also done some biogeographic analysis here. This is the Indian radiation, the one in pink, and all of this part of the phylogeny is African, so there was a dispersal from Africa followed by a radiation in India. And from India, of course, elements, some lineages also dispersed to Southeast Asia. So in plants, there are other examples too. Also, we have this case of single, of course, in Ceropegia, there have been multiple dispersals into India, but one of those dispersal events, the earlier one, is the one that went berserk and there were many, and that it radiated into many species. Okay, so from Ceropegia, it's a different story. Where did they come from? They came from Africa, whereas, the earlier examples, many of them came in from Southeast Asia. How many dispersal events? At least 3. I didn't really go into the details with there, but what is interesting is the earliest dispersal event is the one that radiated, and the subsequent ones were, just one-odd dispersal events, and some of them even might be human-mediated. So definitely this is an endemic radiation. And there are many other examples, a lot of it from my lab. All of these are pretty much from my lab. Tarantulas, agametes, skinks, geckos, langurs. In all of these cases, you have it's mostly from Southeast Asia, a dispersal from Southeast Asia into India, followed by endemic radiation. These are the number of species in this radiation, so it's a lot of species. This is when they dispersed into India, and in brackets is whether there have been back dispersals. So if there is complete isolation, there won't be back dispersal. So in case of India, you do see some back dispersals. Some more examples: toads, freshwater snails, plants. I already talked about, work done by Siddharth. And I've actually left out quite a few other papers here. So you should look up. More and more people are finding that there are these endemic radiations in India, which just goes to prove the point that India has been isolated for a while. It's like an island. And I also have a little star against some of these genera. For example, the frog genus Rao Ocestus, as well as Hemidactylus. These groups have really large number of species in the radiation, and we suspect they are what we call adaptive radiation. Okay, and these are adaptive radiations are again something found mostly in islands, and in India we are seeing some cases of adaptive radiation. I'll have a whole lecture on adaptive radiation in future, but I'll just touch upon it a little bit in this talk. Okay, what about the multiple origin hypothesis? Is there any evidence for that? There are plenty of evidences of multiple origin hypothesis. Remember, in case of the endemic radiation, you have a single origin followed by radiation. Whereas, you could also have a situation where the species found in India do not all cluster together. So there have been multiple origin of that particular taxonomic group in India. And the example comes from macaques. If you look at langurs, it was a single origin. Macaques, a more recent into India, but multiple origins. The species found in India, Mulatta, radiata, and Silenus, line-tailed macaque, bonnet macaque, and rhesus macaque do not branch together. So they are not monophyletic, right? They are all over the phylogeny. So there have been at least 3 dispersal events into India. Mulatta is also found in all the way into China, so it's a much widely distributed species. So, it's just interesting that within primates you have these contrasting scenarios. Langurs earlier dispersal into India, and then a radiation, whereas macaques multiple dispersals, more recent dispersals into India, right? Okay, so in most cases, molecular data support single colonization of these taxa into India, which suggests isolation. Of course, macaques are an exception. I have not talked about, there are many more exceptions. But nevertheless, it looks like endemic radiation is actually quite common. Okay, where molecular data is available or molecular dates are available, the colonization event has been more recent, in the last 50 million years ago. So that's been post India's collision with Asia. So that's when these elements began to come into India. Back dispersals are rare, with only 4 groups exhibiting back dispersals. So, this again goes to prove the point that India has been quite isolated, right? So, upon collision, there was faunal exchange. However, it was not as extensive as previously thought, because subsequently India became an island again, right? So the uniqueness of India's biota is not only due to its diverse origins, Gondwanan, African, Asian, but also due to evolution in isolation, like in islands. These patterns might not be observed in all taxonomic groups, right? So, and in this regard, visuality is an important, very important aspect to look into. Endemic radiations might not be seen in taxa that have high dispersal ability. Now, others have also talked about it, but not explicitly said India is an island. For example, Boxlayas in 2009 says that higher taxonomic level endemism on the subcontinent is not only the result of Cretaceous isolation, but also invasion, isolation, and radiation, right? Of new elements after accretion to Eurasian mainland. So I think India is just a fantastic place, an exciting place for undertaking comparative studies of closely related species, because you have a radiation found within India, and you have these species distributed in vastly different kinds of habitats. For example, Semnopithecus radiation, the langur radiation. You have langurs in the Himalayas. You have langurs in the semi-arid regions at the edge of the desert, a different species. Then you have langurs in evergreen forests in Western Ghats, and the dry zone of peninsular India. They are all related to each other. It's one single radiation, right? So this provides an unique insight into evolutionary processes underlying species diversification. So if we could study these radiations more closely, look at their ecology, look at maybe at the genomic level what's happening, what are the differences, and so on. This will really help us better understand how speciation occurs. So it's an exciting place to do this kind of research. And in fact, it's like an island. So you want related species so that you can do comparative work. So India provides that setting without being an island, even though I'm saying it's an island in the context of this talk. Okay, now let's go back to a real island. This is the island of Madagascar. Okay. Now, Madagascar is the sister landmass to India, right? So India and Madagascar were together. So India and Madagascar is separated from Africa about 120 million years ago, and then India separates from Madagascar 80 to 90 million years ago, say 85 million years ago on an average, and then India moves all the way to Asia in the northern hemisphere. Now, Madagascar has been isolated basically for 80 million years then, 85 million years, right? Whereas India was a true island for about 50 million years, and then after collision merged with Asia, and then we don't know how long it has been the island that I talk about here, probably for 20 million years, but intermittent connections have been there. But Madagascar has been isolated for 85 million years, totally isolated from Asia, from Africa. It's actually quite close to Africa. What do we see in Madagascar? Now, I had the fortune of working in Madagascar for my second postdoc. And I worked on lemurs, and lemurs are an exciting group because it's a island radiation of over 70 species. This number is probably gone up to 90 now. So Madagascar biota provides us with an interesting system to study adaptive radiation of island communities. Now, what is adaptive radiation? As I said, I'll talk more about it in another talk. But for now, adaptive radiation can be defined as a rapid diversification of species from a common ancestor, accompanied by phenotypic divergence and specialization to exploit newly available resources. Right? And often what you see is multiple species in that group tend to co-occur. Right? So adaptive radiation is basically you have an ancestral species that rapidly radiates into many species, again because there are many open niches, and you often see this in islands. So it rapidly uh, diversifies into many species that are adapted to different niches, different ecological zones, and because they are now adapted to different conditions, they often also exhibit extreme morphological disparity. So they look very different from each other, right? Um, so in case of lemurs, just to give you an example, uh, you have lemurs that are, as big as my thumb, and the extinct lemurs, the lemurs that went extinct very recently, so they are part of this radiation. In fact, I did some work where we looked at subfossils of extinct lemurs and basically showed that they indeed fall within the lemur radiation. So in this radiation, you have all kinds of species. Some of them are arboreal, some of them are terrestrial, some of them have amazing adaptations to fish out grubs from within the, the, the bark of a tree. So Madagascar does not have woodpeckers. So there's this weird looking creature called eye, which has got this amazing adaptation to pull out grubs from within stump, within branches, and so on. And then if you bring in the extinct Malagasy lemurs, you have, Megaladapus, which is more like a koala that's found in Australia. It looks more like that. It feeds on leaves. And you have Paleopropithecus, which is more like a sloth, the sloth from South America. And there was also a gorilla-sized lemur, right? So basically, this radiation consisted of something that small to something like the size of a gorilla, terrestrial, arboreal, amazing radiation, right? So this is again a case where there was a single colonization of this lineage from Africa, and because there were so many open niches, rapid radiation, morphological disparity between these members of this radiation, they all look very different. They all occupied completely different niches, right? So that's adaptive radiation. Islands, we see adaptive radiation. Now, turns out in case of India, also there are a few cases of adaptive radiation. In Madagascar, I also worked on this group of lizards called plated lizards. These belong to the family Charosauridae, subfamily Zunosaurinae. They look like skinks, but what basically we found was that it's a radiation in Madagascar, again a single dispersal from mainland Africa into Madagascar, and then a radiation. You don't see an adaptive radiation here, it's just a simple island radiation. Okay, so in case of Madagascar, it's single African origin and an endemic radiation, followed by an endemic, in this case it should be island radiation of Malagasy fauna, right? So you see this in mammals, in birds, in reptiles, in insects, and these stars here refer to adaptive radiation. Remember, in case of adaptive radiation, what you see is, species adapting to very, very different ecological conditions and multiple morphotypes co-occurring. And often these species exhibit morphological differences that are quite extreme, right? Whereas a regular radiation, for example, this would be just a regular radiation. Most of the lizards look overall similar, but they are different species. So In islands, you often find adaptive radiations, and there are many examples of adaptive radiations in Madagascar. Okay, so to wrap this up, as I said, Indian plate and Malagasy plates are sort of sister because they were together and then they separated, went their own ways, and from an evolutionary perspective too, their biotas are quite different today. Madagascar has been an island for a much longer time than India. So, if you look at the number of species in the various radiations in Madagascar, there are more number of species because longer isolation time and greater isolation. Whereas India, it has been porous borders, right, and isolation has been not as long as Madagascar. In India, you see endemic radiation. So you have many species in a radiation, but morphologically they don't look very different, and they are so the radiation is not really an adaptive radiation. And as I said, I'll talk more about it uh, in future. Whereas in Madagascar, you see adaptive radiation. Number of back dispersals. So once you have something coming into an island, you see a back dispersal, right? In Madagascar, you don't see as many back dispersals. In India, you see a lot more back dispersals. So definitely, this means there's greater isolation in case of Madagascar, right? However, you in case of Madagascar, you do see some back dispersals of volant species, that is species that can fly, such as butterflies, and also in some reptiles. But by and large, not many back dispersals out of Madagascar. So that is the story here. I think India is just a fantastic place to address some of these questions. I'm going to follow this up with the whole adaptive radiation story from India. There are a few cases of adaptive radiations in India, and we'll try and understand adaptive radiation in greater depth in future talks. Okay, so that was